Now our Rover was already pretty sweet. It was a mean, lean machine. But you know what would make it 10 times better? A sweet arm, so stay tuned folks, because some of the design considerations I went through might just help you in your next build. Just kidding, I actually have no idea what I'm doing, and don't use any of these designs in your own build process, or at least take them with a grain of salt. Now the reasons you'd want a robotic arm on your robot are, well, pretty obvious. You can pick stuff up, you can move things around, you can get you a LaCroix from the fridge. So we're not gonna go too far into detail. Rather, we're gonna go ahead and focus on the actual arm and some of the design considerations I took, starting at the shoulder joint. Now the shoulder joint took a little more time than the rest, mainly because it takes a lot of torque to move something that's about a foot away from the axis of rotation. To make it harder on myself and keep costs down, I ended up using one of these cheap TT motors. To solve the issue of not enough torque, I ended up using these 3D printed planetary gearboxes, which I designed and built in a previous video. Basically, long story short, for every one planetary gearbox, you get 4 times the torque. So 3 of them, you end up with 64 times the torque, but with friction and some other variables, you end up with about 30 to 40 times the torque. Now for the elbow joint, I cheated a little bit and used one of these 20 kilogram servos that I had laying around. They're not too expensive, but any medium-sized servo should work. This was definitely overkill for what I needed. Moving on to the claw, you can see here I started facing some issues where I couldn't even pick up this baseball, and the reason why is because I was just tapping directly into the output of the servo, which didn't really give me a lot of power. To remedy this, I built this gear system around a 3-to-1 ratio, and this just allowed me to get a lot more torque out of that servo. Now this did limit my range of movement and the speed at which the claw opens and closes, but now I was able to pick up a baseball no problem. I just can't do these sweet claw handstands anymore. Now one last note on the claw side of things, I did put a little bit of hot glue around the edge. This is just to help pick up things, as that 3D printed PLA can be pretty slick. For future projects, I wanted to be able to swap ends on and off Little Timmy without reinventing the wheel every time. To do this, I just made a square notch in the end of the upper arm that can be used to mount anything with the same size square peg. One ability it gives us already is being able to mount the claw horizontally, or vertically, depending on the situation. To mount the upper arm to the elbow, I'm using a 4-pronged servo horn, which I start by attaching directly to the upper arm with 2 M2 bolts. Then I proceed to attach the assembly to the servo. Now for those of you who are cable management enthusiasts, you'll be glad to hear and see that I incorporated just a little bit into the upper arm. With a little bit of persuasion and good fortune, you too might just be able to squeak your servo plug through. No promises though. Tolerances are pretty tight. Now that I have the physical portion finished, it's time to talk wiring. I decided to just use some classic breadboard jumper wires to hook the servos in. The blue wire you see here connects to our claw servo, and it's being poured to pin D10 on our Arduino, as well as of course our power and grounds. The brown wire connects to our elbow servo and is poured to pin D9 on our Arduino. Moving on to our shoulder joint, I soldered some wires onto our TT motor and hooked them into an additional H-bridge which I mounted on the other side of the brain/electronics tower. The H-bridge connects into pins A0 and A1 on our Arduino. Now that we have a very capable robot, allow me to introduce you to one of the many possibilities that you can now do now that you have a robotic arm on your robot. Oh, little Timmy, please fetch me thy LaCroix. Oh, I thank you, good sir. Well, I hope you enjoyed the process of building little Timmy's sweet new arm. And remember, like and subscribe if you want to stay up to date with the newest additions. Up next, sweet fire hose / water gun. Boots out.